Okay, Assalamualaikum warahmatullahi wabarakatuh. Let's continue our 6.3 subtopic, which is coefficient of determination and standard error of estimate. So in this subtopic, they have three important things. Okay, the first one is the coefficient of determination. Okay, and then the second one is standard error of estimate. And then the third one is a prediction interval. So this one, we call it as a coefficient of determination, R square. So standard error of estimate as SEST. Okay. And then prediction interval. Okay. This one is the predicted Y. Okay. Alright. So first of all, let's take a look. What is coefficient of determination? So coefficient of determination is a total variation. Okay, Y, this one is, we call it as a observe Y. Okay. Minus with Y, what we call it, this one, Y, you can find it, what we call this one, okay? So, meaning that coefficient of determination, if the sum of square, so we have summation, square, here, sum of square, of each vertical distances, each point from the mean. So, Y, this one, I call it as a Y, I think Y cross this one, is a mean, mean for Y, and this one is observed Y. Okay. So what is the meaning of vertical? When you look at the graph, okay, this is a vertical line. Okay. Alright. But before that, before we look at this graph, okay, this coefficient of determination can be divided into two. Okay, the first one is a predicted. Okay, the second one is chance. Okay. So for the predicted, we can call it as a explained variation. For the chance, unexplained variation. Okay, you can see that explained variation, we use predicted value with Y mean. Okay, unexplained variation, we use a predicted Y with observed Y. Okay, when you look at the graph, okay, you can see that this is what this is the value of X here. Okay, this one is X. Okay, and then this one here, Y mean, Y predicted, observe Y. Okay, so observe Y with Y predicted, unexplained variation or unexplained deviation. And then predicted Y with the mean Y, explained deviation. So for the total deviation, starting from here until here. Alright. Next. Okay, coefficient of determination. So coefficient of determination can be divided into two also, which is the coefficient of determination and coefficient of non-determination. Okay, so what is coefficient of determination? Coefficient of determination is a ratio of the explained variation. Okay, but and then for the coefficient of determination is a measure for the unexplained variation. Okay. Next is a standard error of estimate. So this one is standard error of estimate. Okay, let's take a look our slide. So our slide, okay, we have total variation. This one is a figure. Coefficient of determination, coefficient of non-determination, standard error of estimate. Okay, let's take a look on the example. Okay, for example, A researcher collects the following data and determines that there is a significant relationship between the age of copy machine. So this one is copy machine. We have 6 copy machines. And then this is the age of copy machine and the monthly cost for copy machine. Okay. And then the regression equation y, so y, this one y predicted equal to 55.57 plus 8.13x. Okay, find the standard error of the estimate. Okay, first of all, we need to find the value for the y predicted. Okay, first of all, we use this formula. Okay, because find the standard error of estimate. So the standard error of estimate, we're going to use this formula. So in this formula, we have y minus y predicted, okay, square summation over n minus 2. So n here is this copy machine. So we have 6 copy machines, so meaning that 6 minus with 2. So we will get 4. And then the value for y is here. So y is here. And y predicted, how to find the y predicted? Using this equation. Using this regression equation, y predicted equal to 55.57 plus 8.13x. So here. So you insert the value for each x. So the first one, x equal to 1. So we will get the y predicted is 63.7. Okay. The second one is for dimension B, x equal to 2. So insert 2 in here. So you will get the y predicted is 71.83. Okay. And then after you get everything, y and y predicted, you must minus y minus with y predicted for each one, for each machine. So 62 minus with 63.7, you will get negative 1.7. And then 78 minus 71.83, you will get 6.17. Okay, so for this one, after you get y minus y predicted, okay, this one y is observe y minus y predicted, and then you must square, you must power of 2. So negative 1.7 power of 2, you will get 2.89. Okay, and then find all the summations for y minus y predicted power of 2. So you will get 169.7392. So 169.7392 divide by 4 square root, you will get the standard, okay, the value for the standard error of estimate is 6.51. Okay, alright. Okay, this is a formula, another formula for standard error of estimate. Okay, how about if we use this formula? So what is the difference between this formula and the previous formula? Okay, so you need to answer this one. Try to find it, why and when we want to use this formula or this formula. Okay, how about let's take a look at the example for this formula. Okay, using the previous example, using also the machines example. Okay, y power of 2, what is y? Where is y? Y is here. Okay, so you need to find the summations for y power of 2. So y, for each y 62, you must square, you must power of 2. So you will get 62, okay, power of 2, 3,844. Okay, try to find all the summations here. So you will get 42,000. Okay, put it in here. So what is A? A is here. A is here. A, 55.57. Okay, this one is the value for A. And this one is the value for B, 8.13. Okay, B is 8.13. Alright, and then Y. Where is Y? Y is here. Okay, 496, and XY, X is here. X you must multiply with Y first, and then try to find the summation for XY. So the summation for XY is 1,778, and divide by 4, you will get the standard error of estimate is 6.48. Okay.